What is necking and ductility, and how does it cause failure? Imagine stretching a piece of chewing gum until it thins out in one spot and then suddenly snaps. That's similar to what happens during necking in materials. When a ductile material is pulled, it initially stretches evenly. But once it reaches its maximum strength, something interesting occurs. Instead of stretching uniformly, the material starts to thin out in a small, localized area. This is called necking because that part looks like a tiny, narrowing neck. Ductility is a material's ability to stretch or deform without breaking. Think of it as how much a metal or plastic can bend or stretch before it snaps. When you pull on a ductile material, it first elongates evenly. But as the load increases and the material hits its highest strength point, the uniform stretching stops. Instead, strain concentrates in one spot. The material in that area becomes thinner and weaker, forming the neck. This localized thinning causes the stress in that tiny region to become much higher than in the rest of the material. Because the cross-sectional area is smaller, the same force results in more stress. This makes the material in the neck deform even faster. As the deformation continues, the stress keeps rising in that small zone, and the material weakens further. Eventually, the neck can no longer hold the load, and the material fractures or breaks apart. Necking is a warning sign that failure is near. It shows that the material can no longer distribute the load evenly. Components made from ductile materials might look fine at first, but once necking begins, failure can happen suddenly. Engineers study necking to understand how materials behave under stress. They can improve designs by choosing materials with higher ductility, which resist necking longer. They can also process materials to make them less prone to localized deformation or shape parts to avoid stress concentrations that cause necking. In the end, necking is a key step in the failure process of ductile materials. It marks the transition from a material that can stretch and bend to one that ultimately breaks. Recognizing how and why necking happens helps us understand the limits of materials and prevent unexpected failures in everyday objects and structures.